Let's go ahead and create some traffic and see this dashboard in action. So here we have overall 16 threads that are running 3 milliseconds in average to send a message onto Kafka. Which processors are actually taking most of the execution time? In this video, we are going to see how to effectively monitor Apache Camel components with Prometheus and Grafana. If you're familiar with Camel developments, you know that out of the box, Camel provides some pretty interesting metrics to follow its performance over time. So it gives you things like average execution times, numbers of successes, numbers of failures, and all of these metrics are available through GMX beans. So if we want to use these metrics in our monitoring stack, which is Prometheus and Grafana, we need to configure something called the JMX exporter, which is a Java agent. And this JMX exporter will pick up the metrics that we're interested in and expose them through an HTTP endpoint. This HTTP endpoint can then be scraped by Prometheus, which can in turn be used by Grafana to build dashboards. The use of Prometheus in this case is pretty interesting if you're planning on deploying your workloads on Kubernetes or OpenShift. So Prometheus will be able to query the Kubernetes API and discover the different instances of Camel that you have deployed. In that way, all the metrics are automatically aggregated and you have some integrated dashboards and a nice overview over everything that is happening in your cluster. So let's first have a look at the GMX exporter configuration here and see what it looks like. Here we can see the configuration, and usually it looks like this. So you set up some pattern that points to a GMX bean or metric. You give it a name, so this will be used as a key for the time series in Prometheus. And you give it also some labels that you can later on use in order to filter the metrics and in order to aggregate them together or perform some operations on these labels here. In the end, what we get is if we plan to deploy our component, we will have the metrics available through an HTTP endpoint like this. And again, you find the key of the metric followed by the different labels and by the value of the metric itself. And so we can view all of these metrics in a dashboard, and this is a dashboard that I have built. This dashboard gives you some filters where you can select the namespace, so that is the Kubernetes namespace that you can filter on in order to get only the projects that are deployed on that namespace. You can filter by Camel context to focus on one specific Camel context. And then you can also filter by route and by processor to focus only on the things that you're interested in. Let's go ahead and create some traffic and see this dashboard in action. So let's run some flows in here. So I'm just sending out 50,000 messages to a Kafka broker through my Camel project here. As you can see, there's some general information about the numbers of running instances of my project, numbers of routes, processors, the in-flight consumers, and about the completion of the different executions here. In here, you can also see the distribution of my deployments. So if I had several nodes in my Kubernetes cluster, it would show up here and I would be able to see where my instances are deployed. So this is something that can help you identify problematic nodes, for example. If we look at the second line, we will be seeing some information about the traffic that is going through the different routes. So each line here represents a route within our project. And we can see that currently there are 5,000 executions per second, right? We can see it's graphed over time in here. So this first graph shows the aggregated performance value over all the deployed instances. Remember, we have 2 deployed instances, and this is just the sum of those 2 instances. If we want to have more details, we can look at the second graph over here. So this shows us per instance what is the performance of each instance individually. So this again allows us to do some analysis and maybe identify some problematic instances if they diverge, if the numbers of executions here diverge over time. Over here we do have some in-flight data. So we can see how many parallel instances are currently running. So here we have overall 16 threads that are running and that are sending Kafka messages. Here again, we have the total number of all instances, and here we have for each instance a separate line. Then on the next line, we have some average execution time analysis. And so here we can again see the sum of everything, and then on a per instance basis. So it takes us about 3 milliseconds in average to send a message onto Kafka for this specific route here. If we want to break down the route, we can look at this table here, which gives us the details per processor. And in that way, we can, for example, identify which processors are actually taking most of the execution time in the route, and then try and optimize it if need to, or just to identify some problematic tasks within our routes. The last line here shows the same thing as the metric above. The only difference is that here we are focusing on only the last 30 seconds. So it's an instantaneous average, right? And that allows us to detect if there's something problematic going on at this instant right now. We would be looking at these graphs here. Okay, so that was it for the dashboard. So this works for Camel 2.x and also 3.x. Given that you have the GMX metrics enabled. It does not work yet on Camel Quarkers, but that's something that I'll be looking into in the future, and I'll probably port this dashboard so that it also works with Camel Quarkers and the micro profile metrics. The micro profile metrics do have some very interesting things there also in terms of performance analysis. It gives you the standard deviations and things like that on the execution times, which we do not have in this case here. So that will be for the future. If you're interested in running this demo, you can go to this GitHub repository where you can find all the instructions in order to run this demo. You can get the dashboard here. I've created a Spring Boot archetype where you can create the Camel project, and it will have all the Prometheus configuration already baked in. If you want to run this example locally, you can do that. Just go over this repo here. It will give you some instructions to kind of emulate the behavior of a Kubernetes cluster on a local Docker installation. So here you get some instructions to install Prometheus through Docker, Grafana through Docker, and with all the dashboards and things like that. So thank you for watching, and see you guys next time.